Okay, so from the flow chart, I told you that the first thing we need to consider when factoring a polynomial is to look for a GCF. So the meaning of GCF is we're looking for a greatest common factor. And what we're going to essentially do is we're going to undistribute it. So let's go back to distribution. If I had 5 and I multiplied it to 2x plus 3, you guys correctly know that to distribute it, right, we're going to get a 10x plus 15, right? And so that pathway is called distribution. But when I undistribute it, right, I'm basically seeing that, well, this is 5 times 2x, and this is 5 times 3. So somebody's already distributed the 5. What we're going to do is undistribute it, or what's called factor it out. Factor out the GCF, right? So the greatest common factor between 10 and 15 is 5. So I'll factor it out. Of course, if I factor it out, I'm right back where I started. So yes, we're going kind of in a complete circle. That shouldn't be any surprise because we just learned how to multiply polynomials. Factoring is breaking them up into products. So this should be full circle. We're basically reversing all our multiplications. And that really typifies that. So this is factoring, where I took 10x plus 15 and I broke it up into a product. So let's practice, right? So when I'm looking at the first one here, 24x minus 15, right, we're looking for what factor is common to both 24 and 15, all right? And when we think about it, I believe it's 3. Of course, if you're not sure, take the time to maybe write out the little products, right? So 24x, we know to be 3 times 8x, and then we're subtracting, well, 15 is 3 times 5. And so I can see, right, what's been distributed already is 3. So to factor it, I'll undistribute it, and what gets left behind is 8x minus 5. And the beauty about this is you can check your answer really quick. Just distribute it back in. And if you get back what you left, that tells you did it right. You don't even need to look in the back of the book. So 3 times 8 is 24, 3 times 5 is 15. So we got it. But again, we took this binomial, and notice it's now broken up into a product, right? This mono times that bi. Broke it up into a product. It's been factored. Number 2. Right, number 2 presents a little bit of a challenge because the leading coefficient is negative. Standing operating procedures, we usually don't like the lead coefficient to be negative, right? So that's going to help us make our decision about what the GCF is. So when I'm looking at these two, right, what seems to be common is the value of 2, but accounting for that negative, what I'm going to do is think of this as negative 2. And so when I pull that negative 2 out, we have to track what kind of gets left behind. So if I factor a negative 2 away from there, what's going to be left is a positive 3x. And if I factor a negative 2 from here, what's going to be left is a minus 7. So 2 times 3 is 6, 2 times 7 is 14, that's no surprise. But I factored out the negative, and so that should change all the signs behind it. Just like when I distribute a negative in, it changes the signs. When I distribute a negative out, it basically changes the signs again. So there would be the factorization. So this monomial negative 2 times this binomial 3x minus 7, these are the two things I would have to multiply to get this binomial. And of course, how do you check it? Just redistribute it. Negative 2 times 3x is negative 6x. Negative 2 times a negative 7 basically is positive 14. And we're off to the races, so we did a good job. So next one. Again, leading coefficient is negative, so I'm going to pull a negative out of there. What seems to be common between these two? Well, number-wise, it looks like it's 9. And then variable-wise, they both have at least x in it. All right, so what I'm going to be factoring out of this is the monomial negative 9x. And so what gets left behind? Well, 9 times 2 is 18, and x times x would give us x squared. So again, you can just do a really quick check. If you multiply these two, you get negative 18x squared. If I factor this away from itself, right, what's left is 1. Negative 9x times 1 is negative 9x. All right, so when you factor something away from itself, what's left is 1. We went through a sign change because we factored the negative out. And so again, there's your factorization. This monomial times this binomial creates that binomial that I have here. We broke it up into a product. And again, a really quick distribution proves that we're right. All right, and so just keep on trucking here. In the next stanza, right, when I'm trying to make it a little more challenging, there's not a binomial, there's actually a trinomial, but the idea of a GCF remains the same. What item is involved in all three terms, right? What's the common factor, the greatest common factor of all three terms? Well, for sure we see that x is common to everybody, and 6, 9, and 15, they all have a common factor of 3. I don't need a negative because my leading coefficient is already positive. So what gets left behind? Well, if I factor 3x away from here, what's left is 2x squared. Again, do a quick multiplication and you'll get that term back. Plus, well, if I factor a 3x from here, what's left is 3x. And then last but not least, if I factor from here, what I get is a 5. How do I check? Just multiply it back through, distribute it, right? So this times this is 6x cubed. This term times this term is 9x squared. And that term times that term gives us a 15x. Excuse me, that cost been waiting to come out. All right, and so basically we factored. So we have this monomial times this trinomial, right? These are the two things I multiply to create that trinomial right there. All right, and we're good to go. Number 15. Again, I have three terms. What's common to each one of these three terms? What's the common factor? Well, everybody has at least one x in it. And then 18, 24, and 12, I believe the thing that's common to all of those is 6. Okay, and so when I pull that 6 out, what's left behind here is 3x squared. What's left behind there will be a negative 4x. And then what's left behind here will be a plus 2. And again, to check, just redistribute it. So this times this is that guy. This term times this term is that guy. And this term times this term is that guy. But we're looking for the factorization. What two things can I multiply to create the trinomial that I have? And then last but not least, I have a trinomial with the leading coefficient that is negative. So we know we're pulling a negative out of there. Everybody has an x in common. And for sure, everybody has a 4 that's common. So the term, the monomial I'm going to factor out or pull out or undistribute is negative 4x. So going through, what's left behind here is x squared. Changing the signs, we get a negative 3x. And then right here, that'll be a plus 1. And then again, quick check, this term times that term gives us that guy. This term times that term gives us this dude. And this term times 1 gives us itself back. So you just broke it up into a product. So that is why we're going to use the GCF first. Whenever I ask you to factor a polynomial, if you remember the flow chart, the first thing you consider is there a GCF? It does two things. Number one, it gets things started. It's the easiest technique we can use. And then number two, it makes all the numbers easier to use in the next phase when we start asking how many terms. So very, very good thing to get into. There's one more little nuance about a GCF, but this video is already a little lengthy. I'm going to cut that into the next video. So one more thing to address GCF-wise. I'll see you guys in the next video.